up, what up? I'm the math teacher Goat, and today in AP Precalculus land, we are doing a full lesson on 1.11, equivalent representation of polynomial and rational expression. Now, if I could give an award to my least favorite section of Unit 1, it would definitely go to this guy right here. It's a doozy. If you're looking at this right here, you might be like, no, no, no. Yeah. And then if you're wondering what that guy is, we'll talk about it soon. Like and subscribe. Download the notes in the description of this video. Download them, print them, use them. They're for you. All right. Okay. So we're going to talk about two main things. But before we talk about the one main thing, let's just make sure we're good with foiling. Foiling. Curses. Foiled again. Remember that? Anyway, x times x, 3x squared is 3x cubed. X times 2 is 2x. Negative 11y times 3x squared. I got ahead of myself. Negative 11y times 3x squared is negative 33x squared y. And last but not least, negative 11y times positive 2 is negative 22. Oh, shouldn't do that. Copyright. All right, that was cool. Now look at this thing over here. This is called Pascal's triangle. Now we're going to make this on our own several times throughout today's lesson. But first you need to take a look at it and memorize it. This is the pattern of Pascal's triangle. The outside is always ones. This is a 1. And then this is a 1 and a 1. Then the way you write out the next row is you keep ones on the outside, and the middle and underneath is going to be the sum of the upper numbers to its sides. So 1 plus 1 is 3, and 2 plus 1 is 3, and 1 plus 3 is 4, and 3 plus 3 is 6, 3 plus 1 is 4, so on and so forth. One's on the outside. Now, this is what I mean by labeling it. We are going to label the first row degree 0. I don't know why I wrote out dog, but I'm leaving it. Degree 0, degree, I'm not editing that out. The second row is degree 1, third row is degree 2, fourth row is degree 3, fifth row is degree 4, sixth row is degree 5, seventh row is degree 6, eighth row is degree 7. Okay, now this is used for a god-awful train wreck thing called the Binomial Theorem. Okay, so we will rewrite the Pascal's triangle. Nothing to memorize. Like I said, you just write out 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And I'm getting this by doing 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, 1, and then so on and so forth. And then degree 0, degree 1, degree 2. Right now, none of this makes any sense, and you're like, what the freak? Well, maybe you did do it in Algebra 2, so you might not be going, what the freak? But you're about to in a minute. Now, binomial theorem is awful. I hate it. You're going to hate it. And I'm going to be honest, it's one of those things where you're going to learn it, you're going to memorize it for like a day, and then it won't reappear until maybe a test on Unit 1 and then the actual AP exam itself. So it seems very frustrating that you have to do all of this, but it's all right. This is how I do the binomial theorem. I like the way I do it. What you're going to do first is you're going to label A and B. So the first term in a parentheses is going to be A and B. What the binomial theorem does is it lets you FOIL things out without having to actually FOIL it. You're given something like A plus B to the n, and you're going to have to FOIL it out. Okay, now I'm going to label X A, and B is going to be negative 5. Okay, so A is X, B is negative 5. Then what you're going to do is you're going to make yourself Pascal's triangle. So I care about going to the 4th degree. Now, why the 4th degree? Because the degree is 4. So row 1 is degree 0, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now I went 5 rows because it's degree 4. And so degree So since your degree 0, your degree 1, your degree 2, your degree 3, degree 4 is going to be that guy right there. What you're going to do is you are going to use this as the row in Pascal's triangle and write out those numbers. Now spread them out. Write out 1, 4, 6, 4, 1. Okay, maybe I should have given myself a little bit more space. I'm trying to give myself a little bit more space. I think that'll be all right as I move things piece by piece. Okay. Then what you're going to do is you're going to take the fact that we have an a. Okay, now don't plug anything in yet. Just take a and write out a to the 4th, a to the 3rd, a squared, a, no a. Do the same thing with b, but go from the right. So b to the 4th, b cubed, b squared, b, no b, and put plus signs in between everything. Now let's plug in what we labeled. So 1, a squared is going to be x, I'm sorry, a to the 4th is going to be x to the 4th, plus 4. A to the 3rd is going to be x to the 3rd. B on its own is going to be negative 5. Plus 6. A squared is going to be x squared. B squared is going to be negative 5 squared. Plus 4. A is just going to be x. B to the 3rd is going to be negative 5 to the 3rd. Plus 1. B to the 4th is going to be negative 5 to the 4th. Okay, then we simplify. 1 times x to the 4th. I'll clean that up. 4, x to the 3rd, negative 5. I didn't really do anything. I'm just taking care of the exponents first. 6, x squared times 25. 4, x times negative 125. Plus 1 times positive 625. Now let's clean that up. X to the 4th is just x to the 4th. 4 times negative 5 is negative 20, x to the 3rd. 6 times 25 is 150, x squared. 4 times negative 125 is negative 500, x, and then plus 625. So the binomial theorem gives you a step-by-step process that allows you to not have to foil, 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 and foil again. It just goes right here. Not pretty. Not one bit. Oh, man. All right, I didn't do a good job leaving myself space, but that's okay. Degree 3, you're my A, you're my B. Okay, so I need 4 rows, so 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. What you're going to do first is write out the numbers in the row that you care about. So I care about 1, 3, 3, 1. Start from the left and use your degree and work your way down. A to the 3rd, A squared, A, no A. Go to the right and work your way down. B to the 3rd, B squared, B, no B, plus signs in between. Plug stuff in. A is 2x, so 1 times 2x to the 3rd, plus 3, a squared, so 2x squared. B is positive 3, plus 3, a is 2x, b is 3 squared, plus 1, b is 3 cubed. Two times 2 times 2 is 8, x to the 3rd, plus 3 times 4x squared times 3, plus 3 times 2x times 9, plus 1 times 27. And we'll just clean this up by writing it out one more time. 8x to the third. 3 times 4 is 12 times 4 is 48, so 48x squared. What would that be? 29, 54x 27. Yuck. Yuck. Right, this is what I'm going to do. I'm going to really blow this guy up so I have the space. Because I'm going to need it. I'm going to need it. All right, I need 8 rows of Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 2, 3, 4, 5 rows. So I need 3 more rows. 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 5, 1, 1, 2, 3, 4, 5, 6, 7. I need 1 more. 1, 7, 21, 35, 35. Uh-oh, that should have been 6. 21, 7, 1. All right, let's write out the coefficients. I need that, all of them. 1, 7, 21, 35, 35, 21, 7, 1. Okay. Do A and work your way down. A to the 7th. So A to the 7th, A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A squared, A, no A. Do the same thing with the right side with the B's. B to the 7th, B to the 6th, B to the 5, B to the 4, B to the 3, B to the 2, B, no B. Plus signs in between. You can see why I hate this process. It's just not fun. It's just not fun at all. All right, A is x, B is 2. 1 times x to the 7th plus 7 times x to the 6th times 2 plus 21 times x to the 5th, 2 squared plus 35 x to the 4th, 2 cubed, plus 35 x to the 3rd, 2 to the 4th, plus 21 x squared, 2 to the 5th, plus 7 times x 2 to the 6th, plus 1 times 2 to the 7th. All right, you just become x to the 7th. That'll become 14x to the 6th. Let's see if we can do this in our head. 21 times 4 is going to be 84. X to the 5th. So it'll be 35 times 280. X to the 4th. Plus 35 times, that'll be 16, that'll be double that, so 560, x to the 3rd, 2 to the 5th is 32, 32 times 21, 672, I did not pause it and look up the answer. Plus that'll be 7 times 2 to the 6th. 2 to the 6th is 64. 7 times 64, 448. X plus 64, 128. Oh! I hope I'm right. If I'm not, leave a comment, but that seems like it should be okay. That seems like it should be okay. Binomial theorem. Barf. Barf, 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 barf. And looks like I'm doing it again and then again. Ooh, all right. Okay. 4 rows of Pascal's triangle. 1, 2, 3, 4. Write out your coefficients first. 1, 3, 3, 1. Scoot you over. What do we have? A degree of 3, a to the third, a squared, a, and then so b to the third, b squared, b plus, plus, plus. A is 3x, so this will be 1 times 3x cubed, plus 3 times 3x times negative 1 is going to be my b. So negative 1 plus 3 times 3x times negative 1 squared plus 1 times negative 1 cubed. Okay, that one's not necessary. 3 times 3 times 3 is 27, so 27x cubed. 3 times 3 is 9 times negative 1 is going to be negative 9x. 3 times 3 is 9 times negative 1 squared is going to be 1, so plus 9x. Forgot a squared there, didn't I? And then 1 times negative 3, 1 times negative 1 times negative 1 is going to be minus 1. One more time. We've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and that's the row we care about. 1, 4, 6, 4, 1. Degree of 4, work your way from the left. A to the fourth, a to the third, a squared, a. Go from the right, b to the fourth, b to the third, b squared, b, plus signs in between. Plug it in. You are my a and you are my b. 1 times x to the fourth plus 4 times x to the third times positive 2y plus 6 times x to the second, 2y squared, plus 4 times x times 2y to the third, plus 1 times 2y to the fourth. All right, let's do some mental gymnastics here, because I'm running out of space. 1 times x to the fourth, x to the fourth. 2 times 4 is 8, so 8x cubed y. Plus 6 times 2 squared is going to be 6 times 4, which is 24. X squared, y squared. 4 times 2 to the third is 4 times 3, so that's going to be 32xy cubed. 2 to the fourth is 16 times 1 is 16, so we'll have 16y to the fourth. All right, so gross. But we did it. Now, that was part 1. Part 2 is not so bad in my book, but, some people still don't like it. A slant asymptote, also known as an oblique asymptote, but I will never once call it oblique asymptote ever again. So a slant asymptote occurs when the graph of a rational function, when the degree in the numerator is exactly 1 more than the degree in the denominator. So you have to have something like blah, 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 x cubed over blah, 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 x squared. You can't have x to the fourth over x squared. That will not give you a slant asymptote. Okay? Now, the way we find out, slant asymptote is this linear equation, this linear line right here, which means it's going to be linear. It's going to be in the form of y equals mx plus b. But before we can even consider that, we need to remember our old friend polynomial long division. Now, if you want to see what synthetic division looks like, I have videos on the old YouTube. Look them up. I will only do polynomial long division. So we're going to do x minus 3, x squared minus x plus 2. Polynomial long division, you're going to take your factor, and you're going to see how many times that first term goes into the first term here under the dividend. So you have x times what is x squared. X times x is x squared, write it above x squared. Take that x and multiply it to your factor and write it underneath. X times x is x squared. X times negative 3 is negative 3x. Then what you do is you subtract the entire row, which means you flip the signs of everything. You become a minus and you become a plus. Now you add these two. Add them. So x squared minus x squared is always going to go away. Negative x plus 3x is 2x. Drop down the next part plus 2 and repeat. Okay? X goes into 2x 2 times. Take that 2 and multiply it to your factor. 2 times x is 2x. 2 times negative 3 is negative 6. Subtract the entire row, which means flip the signs. You become a minus, you become a plus. Add these guys up. Cross u out. 2 plus 6 is 8. And so you get a remainder of 8, which technically means 8 over x minus 3. And that would be your solution. Now, we're not going to care about that after this problem, but that's what you would get. Let's do it again, remembering to be very, very, very careful. Here's our factor, 2x cubed plus 3x, and I'm going to add a plus 0 there because we need it. Similarly, 6x cubed plus 13x squared, I'm going to have to include a 0x minus 5. Keep in mind, polynomial division only works if things are in standard form, and if you have any in-between stuff, you include a 0 there with it. So let's do this process again. All right, let's do this process again. Let's scooch in just to u and only focus. Will it let me do that? Nah, it's all right. It's okay. That's okay. 2x squared goes into 6x cubed. Let me see, 2 goes into 6. 2 times 3 is 6, and x squared times x is x cubed. Now take that 3x and multiply that to everything. Okay, 6x cubed plus 9x squared plus 0x. Subtract the entire row, which means flip the signs. You become a minus, you become a minus, and you become a minus. This will always cross out. 13x squared minus 9x squared is 4x squared. And 0x minus 0x is 0x. Drop down minus 5. Do it again. 2 times what is 2x squared times what is 4x squared? Well, 2 times 2 is 4, and the x squareds are already taken care of, so it's just a 2. Multiply that 2 to this entire thing. That gives us 4x squared plus 6x plus 0. Subtract the entire row, which means you flip the sign, so you become a minus, you become a minus, you become a minus, you will always cross out, you become negative 6x, and then you become minus 5. I can't go any further, so that's our remainder, which means our answer is 3x plus 2 plus negative 6x minus 5 over our factor, which was 2x squared plus 3x. Why did I do polynomial long division after talking about slant asymptotes? Well, the equation for the slant asymptote is found by doing polynomial long division. Yay! So let's do just that. Let's find the equation for each slant asymptote. Now, a slant asymptote is in the form y equals mx plus b, which means I don't care about remainders. Once I get to this point, y equals mx plus b, I am done. You have a slant asymptote because the degree in the numerator is 1 more than the degree in the denominator, so we can proceed. We've got x squared minus 2x plus 1, and we're going to divide into x cubed minus 2x squared minus 4x plus 1. Everything is in order. X squared times what is x cubed? Just x. Take that x and multiply it to everything. X cubed minus 2x squared plus x. Subtract the entire row, which means flip the signs. Minus, plus, minus. You go away. You go away. And that way you can drop down minus, what would that be? 3x, and then drop down plus 1. Now we're done here. And before you're like, oh, the remainder, we don't care about the remainder because the remainder is not in this form. So all we have to do is say the slant asymptote is y equals whatever that is, x. Perfect slant asymptote. Perfect. Perfektenschlag. The Office. If you ever watch The Office, you know what I just did there. Let's do it again. X plus 6. It's going to go into x squared minus 9x plus 4. Everything is in order. Don't have to worry about stuff missing in between. X goes into x squared x times. X times x is x squared. X times x is x squared. X times 6 is 6x. Subtract the entire row, which means flip the signs. So u will always go away. Negative 9x minus 6x is negative 15x. Drop down the plus 4. X times what is negative 15x? X times negative 15 is negative 15x. Stop. Now the reason why we could stop is it doesn't matter from here on out. I now have something in the form y equals mx plus b, because if I were to keep going, the only purpose it's going to serve is to find a remainder, and I don't care about it. So x minus 15 means I'm going to have a slant asymptote of y equals x minus 15. Okay. Let's keep going. Let's keep going. Nothing crazy about this, just a few coefficients. 2x plus 1, 4x squared plus 12x minus 6. 2x times blank is 4x squared. 2x times 2x is 4x squared. 2 times 2 is 4. X times x is x squared. 2x times 1 is 2x. Subtract the entire row, which means flip the signs, minus, minus. You will always cross out. You become 10x, drop down the minus 6. Okay, 2x goes into 10x how many times? 5. Stop. Because now we're in the form that we want, mx plus b. So our slope, or our slant asymptote, is y equals 2x plus 5. And that is that. This one's a nightmare because there's stuff missing and everything's not out of order, but there's just stuff missing. So I have 3x cubed minus 4x squared plus 0x plus 0 is going to go into 9x to the 4th plus 0x to the 3rd minus 5x squared plus 3x minus 6. Ugh. Ugh. 3x to the 3rd goes into 9x to the 4th 3x times, because 3 times 3 is 9, x cubed times x is x to the 4th. Take that 3x and multiply it to all 4 of those things, so you become 9x to the 4th, you become negative 12x cubed, you become 0x squared, and 0x. Subtract the entire row, which means flip the signs for everything. So you become a plus sign, you become a minus sign, not that it matters, and you become a minus sign, not that it matters. You will go away, drop down 12x to the 3rd, drop down minus 5x squared, drop down plus 3x, drop down minus 6. 3x cubed times blank is 12x cubed times 4. Stop. We now have y equals mx plus b form. Y equals 3x plus 4 is going to be our slant asymptote. Ugh. Pretty crazy stuff. I told you this wouldn't be fun. At least I'm having a great time. I'm having a great time. Now let's put a lot of this together. Barf, barfy, barf, gross. All right. So they want domains, zeros, holes. So we're basically taking everything that we've learned and kind of like putting it all together. So let's factor it over here where I should have enough space. Let me give myself just a little bit of room. I think that should do it. I don't know if that even made any difference. Let's pull out 3x squared Nope, just the 3x. My bad. Bad start. We can pull out a 3x. That leaves me with x squared minus 4, convenient, over you factor out to x minus 4, x plus 2. The top part factors out again, so 3x, x minus 2, x plus 2. The bottom factors out to x minus 4, x plus 2. Magic number time. 0, 2, negative 2, 4, negative 2. 0 is a 0, 2 is a 0, negative 2 is a whole because negative 2 is a whole, and 4 is a vertical asymptote. All right? All right. The domain. I'm not allowed to plug in my magic numbers in the denominator, so I'm not allowed to plug in 4 and negative 2, so my domain is going to be infinity up until negative 2, union negative 2 to 4, union 4 to infinity. My zeros are 0 and 2. My wholes are at negative 2. My vertical asymptote is going to be 4. My degree in the numerator is higher than the degree in the denominator, which means I'm getting a slant asymptote, which means I'm not getting a horizontal asymptote. Now let's find our slant asymptote. So we got x squared minus 2x minus 8. We're going to divide that. 3x cubed plus, oh, don't forget, 0x squared minus 12x plus 0. Do some polynomial long division. X squared times 3x gets me 3x cubed. 3 times x squared is 3x cubed. 3 times negative 2x is negative 6x squared. 3x times negative 8 is going to be negative 24x. Subtract the entire row by flipping the signs. So you become a minus, you become a plus, and you become a plus, and you cross out. 6x squared plus 12x, drop down to 0. Blank, or x squared times blank is 6x squared, 6. We could stop right there because we're already given something in slope-intercept form, and that is y equals 3x plus 6. To find the y-intercept, you're going to make believe that all of the x's are zeros. So if all of the x's are zeros, then the top is going to be 0. The bottom one's going to be negative 8, which gives me a y-intercept at 0. Because 0 divided by negative 8 is 0. My x-intercepts, I already know that already because I found them. Those are 0 and 2. And the end behavior is defined by the slant asymptote. Since the slant asymptote has a positive slope, I know that this is going to go up and to the right and down and to the left. So the limit as x approaches infinity of, what was this, f of x is going to be positive infinity. And the limit as x approaches negative infinity of f of x is going to be negative infinity. Woo! Look at us putting everything back together. Look at us being builders. Builders of learning. Builders of fun. All right, last page of this abomination. The function f is a rational function. The quotient and remainder form of f is given by that. Okay, so you're dividing. Okay, that's weird. Which describes the end behavior of f. Oh, okay. So the quotient and remainder form of f is given by negative 2x plus 1 plus that guy. So they are telling you right now that this is your slant asymptote is y equals negative 2x plus 1, which means your slant asymptote is going to look like this. So something like this will happen, right? Or, so bang, or something like this will happen. Either way, you're going up and to the left and down and to the right. So that means the limit as x approaches negative infinity of f of x is going to be positive infinity. So not you, not you, you. Similarly, the limit as x approaches positive infinity of f of x is going to be negative infinity. Not you, you. Here we go. You ready? Are you ready? F of x is a quartic. G of x is a quadratic. Also, h of x is going to be f of x over g of x. Circle each correct statement. H of x has a remainder of 0 when using polynomial long division. All right, let's find out. So we have x squared plus 2x minus 3, and we're going to divide that into x to the fourth plus 8x to the third plus 18x squared plus an invisible 0x minus 27. X goes into x to the fourth x squared times. X squared times x squared is x to the fourth. X squared times 2x is positive 2x to the third. X squared times negative 3 is negative 6x squared. Subtract the entire row, which means flip the signs. You will go away. You become 6x cubed, and you will become 24x squared. Drop down the 0x. Repeat. X squared times 6x is going to give me 6x cubed. Multiply 6x to that, so 6x cubed plus 12x squared minus 18x. All right. Subtract the entire row by flipping the sign, so you become a minus, you become a minus, you become a plus. You go away. You become 12x squared. You become 18x. And minus 27 drops down. X squared times 12 is going to be 12x squared. 12 times x squared is 12x squared. 12 times 2 is positive 24. Bring the x along. You become negative 36. Subtract the entire row by flipping the signs. So you become, let me use a different color. You become minus, minus, plus. You go away. You become negative 6x, and you become 9. That's my remainder. So the remainder is 0? Nah. Now you were a quartic. You were a quadratic. You're x to the fourth. You're an x squared. Can that have a slant asymptote? No, because you'd only have a slant asymptote if the degree in the numerator is higher by 1 and only 1. C, I'm being asked to find if I can rewrite f of x as that guy. So let's do this. Let's be clever here. Let's use Pascal's triangle and do that with just this part right here. So let's just, that's kind of the reason why I did this binomial theorem. So I need 4 rows. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Okay, so let's write out 1, 3, 3, 1. A squared, A, oh, my bad. A cubed, A squared, A, B cubed, B squared, B, plus signs in between. You're an A, you're a B, so this becomes 1 times x cubed plus 3 times x squared times 3 plus 3 times x times 3 squared plus 1 times 3 to the third. So you become x cubed, you become 3 times 3 is 9, 9x squared. You become 27x, and you become 27. Now that's just this part. So I'm still going to FOIL that with x minus 1. So x minus 1 times x cubed plus 9x squared plus 27x plus 27. You ready? X to the fourth, 9x to the third, 27x squared, 27x. Okay, negative x cubed, negative 9x squared, negative 27x, negative 27. Putting that all together, we have x to the fourth minus 8x cubed plus 18x squared plus nothing minus 27. Please, 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 thank you, God. Whew. That was a doozy. That was a doozy. Make sure you go back to my YouTube. You type out AP Precalculus 1.11, and I'm going to give you some random problems that I do that could help further your knowledge. They're going to look like this. Please like and subscribe. It goes a long way. My YouTube's slowly growing, but it's growing, so please help me with that. But yeah, man, that was a tough one. But hopefully this helps. Hopefully this helps. Hopefully this helps. Thank you guys for watching. Thank you everybody who's dedicated and leaves their comments. I really do appreciate you. You guys are the best. Love you all. Bye.